Thank you for coming to this session. I'm very excited to see you all. Hope you find this session very useful and walk away with some interesting insights and learning. Before I get started, I want to ask a couple of questions. So, how many of you are aware of StarTree and Apache Pinot? If you can raise your hands. Oh, that almost looks like full house. How many of you are aware of StarTree ThirdEye? Okay, there are a few. Obviously, StarTree folks know what is StarTree ThirdEye is. If you are not familiar with StarTree ThirdEye, are you using any anomaly detection solution? If you can raise up your hands. Okay, looks like we have a couple of people who are trying to learn for the first time. Well, we'll try to make sure you get the most out of it. With that, I will quickly introduce myself. I know Varkha has introduced, but I just wanted to say that I've been with StarTree for some time and working in StarTree ThirdEye especially, and my journey starts from way back in LinkedIn, where I got to work with our CEO, Kishore, and since then until now, the journey has been incredibly rewarding. And today I'm sharing the stage with Will, Cyril, Subhadeep, who are the talented engineers behind making anomaly detection work in real time at scale on top of Apache Pinot. So when they come up on stage and talk about their part, they are going to introduce themselves and share some interesting things that they have to share with you. So with that, I would like to kick off and have this theme up there. DoorDash scales its operational excellence with confidence. The reason behind is they are enabling the real-time anomaly detection across 500 plus API partners. And this is all powered by StarTree ThirdEye. And today's talk is going to be that, and that's the focus. And we will be talking about that. In the intro, the agenda would look like this. I will be quickly talking about StarTree ThirdEye overview, the why and what and how it evolved, and then will give us a walkthrough of DoorDash success story, and Subhadeep and Cyril will talk about the technical innovations and work done behind the scene that is enabling real-time anomaly detection at scale. So first, I'm sure all of us are aware what metrics is. I do want to touch upon one more time what the what and why metrics are critical. When you bring it more real time into the context of play, that's when it becomes more challenging, interesting, and the importance doubles down. I'm not going to read the entire thing that is listed here. There are different use cases of metrics that has been listed, but I do want to touch base on few. The website traffic spike. So now the website traffic spike can have two angles to it. One is the business implications, another is the system implications. So what's business implications? A good reason is if there's a spike on your traffic, and if you're running a campaign behind the scene and that's causing the spike to happen, that means there's some interesting growth opportunity out there. Your campaign is doing something really good. And based on those insights, you can make data-driven decisions to whether to run the campaign further or not. The other angle to it is if you're seeing the load increasing gradually or suddenly, you do want to know early on so that you can optimize your resources behind the scene. So that's the part why I was trying to touch base that both angle, it is extremely important, it's critical. And what is happening right now is as the data is growing, it is becoming challenging and nobody is sitting and staring those dashboards to know this is what's happening. It's interesting that when I was at LinkedIn, I was working with business operations team. And there's a group of people who come and stare at a dashboard every day and night and looking for what are the business growth opportunities they can unlock. And I first time introduced ThirdEye, they tried, and it was a game changer for them because they felt, oh, now we can sleep and not worry about looking at the dashboard. Our boss is not going to scold, like I didn't check my dashboard today and I missed something. So that's the power of monitoring those anomalies in an automated fashion. So now that we talked about metrics monitoring, let's talk about anomaly detection, why it is important. So when you monitor those metrics, there's obviously outliers, and all of us are probably very well aware the spikes and drops. And that gives us, of course, a good signal, something going wrong with your data, you should look up. But there are times where there is gradual change in your metric. And sometimes these gradual changes are expected, sometimes it is unexpected. But if you are playing around with large scale of data, and it's very hard for a human to understand the gradual change and act towards it. So that's where the anomaly detection comes into play, that gives you the signals, and then you can make data-driven decisions with confidence. Now, just detecting the outlier is not enough, because in order to make decisions, you need to know what has caused this change. And that's when there could be several factors associated, external, internal, and that comes into play, and that gives you the insights that are necessary so you can make relevant decisions based on that. Now that we talked about metrics and anomaly detection and its importance in doing all of these in real time, let's talk about what are some of the growing challenges as the tech is evolving. What are the growing challenges if you were to use anomaly detection at your company, or if you are already using something, what issues it can run into possibly in future. So these are some of the growing challenges. Of course, this is not limited to this, but I just wanted to call out, it's very obvious, and we see the trends clearly indicating that. First, of course, we've been talking real-time detection, why it is critical, but as your data is growing, the high dimension data is also growing. So what does it mean? If you're trying to monitor a metric at a global level, you're not getting enough signals whether the problem lies at a granular level or at a global level. And that's where the complexity arises, because doing this at scale is extremely difficult, going that granular and detecting those fine-tuned anomalies. Now that we are talking about the high dimensional data, there's also patterns involved in this data. There are various types of patterns, distributed patterns. Sometimes your data is seasonal, and sometimes there are metrics that are gradually upward trending or downward trending, and it could be expected, it could be unexpected. So one good example, why I want to touch base on the pattern especially, because if you're doing detection or outlier detection on top of it, and say you are using just threshold-based alert, and it's an expected behavior, your metric is gradually trending, it is okay for your business. But what happens if you enable threshold-based alert? It will give you false alarms as the metric changes. And then it will cause alert fatigue, and somebody needs to go manually keep changing the threshold. So now what happens is, if you look at the historical pattern and then detect, that would be the right way to go, at least for these kind of trend detection. However, this is also doing it in real time at scale is extremely challenging, because you will run into alert fatigue for sure. Then once you detect those alerts and anomalies, explainability is a big challenge. Again, as I was mentioning before, whether it is happening at a global level, whether it's happening at a cohort level, or it is just local problem. So getting those insights in real time is extremely challenging. So that's another challenge, growing challenge we notice. Last but not least, cost of operations. So as most of you are probably belonging to a data team, so you have a wide range of stakeholders who are working with you. You're closer to the problem. You know what is going on with the data. But there are a bunch of people who are, in fact, consumers of data. They don't know what's going wrong, and they bombard people with a lot of questions, and a lot of time goes on servicing those requests instead of focusing on making your platform robust and great, or applications great. So that's another problem that is arising with all the data landscape. Then scalability is another one. If you're quickly growing, then how you can scale this anomaly detection to multiple users and multiple problems and use cases. That's another big challenge. And extensibility. So once you have the anomaly detection, the extensibility is a big picture that comes into play, because knowing what is wrong, that's not enough. You need to act on it. And that's where the ecosystem integration extensibility part comes into play. So these are the growing challenges, and this is not something happening now. It's happening for a while. And our founder and CEO, Kishore, who noticed these growing challenges when he was sitting in the war rooms at LinkedIn. And he thought, like, building an anomaly detection on top of Apache Pinot, probably going to solve a lot of challenges that we have listed here. So that's how ThirdEye was born. And it has 3 parts. It is powered by Pinot, so it can blend historical data and live data together. And the problem that I was highlighting before, when gradual changes happen, you're looking at the pattern and learning that in the real time and predicting what's going wrong. So it can do that effectively. And if you're playing with the massive data, then you're running a lot of queries and aggregations on top of it, which is very much needed. And every time you have unique use case for your business and you're trying to create the right data, that you lose time. But with ThirdEye, you are able to do that on the fly. You can run those queries and then apply the algorithm to detect anomalies. One thing I would like to also highlight, these detection we configure with a lot of flexibility. We give it in the hands of users, so you can apply your business context and get those accurate anomalies. Accuracy is always top of our mind. And a lot of solutions failed before because the accuracy was a concern. And last but not least, the interactive UI we have for getting heat maps or dimension granularity in real time you can do. So once the anomaly is detected, you can source these details. And more, I think, Will and Subhadeep and Cyril will be covering, so I won't talk a lot here. We have also APIs that will help you to integrate the extensibility part that I was talking about. So since ThirdEye is powered by Pinot, I can confidently say that one can make data-driven decisions with confidence. Here are a few most liked features that users have highlighted. So apart from doing the detection and root cause analysis on your live data, we allow you to do multidimensional granularity detection, which will show in action. And we have advanced proprietary algorithms. Cyril is going to talk about it, and Subhadeep is going to talk about overall the architecture and how we have the low-code, no-code UI that is enabling you to do a lot more things, that is enabling ThirdEye to be the real-time monitoring solution at scale. So with that, I will hand over to Will, who will go through the next set of slides.
Thanks, Madhu, for the intro. Again, I'm Will. I'm a software engineer at DoorDash. I've been working with Pinot for close to 3 years now, trying to onboard use cases at DoorDash as well as platformize it. And yeah, today I'll be covering a use case that we worked on last year involving ThirdEye. So a bit about DoorDash, though I'm sure many of you already know. DoorDash is a leading local commerce platform connecting customers with their favorite restaurants in over 6,000 cities across North America. While the food delivery aspect of DoorDash is well known, beyond restaurants, the platform also powers convenience stores, pet stores, grocery stores, and more. And so because we have this platform, there's obviously going to be a lot of data and monitoring needs. Some examples: order management, customer behavior, delivery efficiency, restaurant performance. But the one of focus today, which relates to the ThirdEye use case, is partner insights. So about the problem. So with DoorDash, we have something called our Drive platform. So this is for essentially larger restaurants or merchants who don't necessarily want to use the DoorDash app on your phones that you and I use. They might have their own website or some other way of allowing people to order or make a delivery, but they want to utilize, for example, DoorDash's Dasher driver network. And so for that, we have a special platform where they won't use our UI, but they, like kind of the back end behind the dashers they would use, and that's called Drive. And so they integrate with us in our APIs, and we have over 500 partners who work like this. Obviously, though, from time to time, there will be issues with integration. Previously, these partners were notified manually by ops teams when such issues occurred, but that isn't really scalable, or is it reliable, because, yeah, the time that it takes for someone to manually notify our partners could be quite variable. So at DoorDash, there's a developer insights team, and they are the ones who manage like this Drive product. So they wanted to identify API issues in real time on the order of 5 minutes, and they wanted to have like an automated system to notify partners when this happened. And one of the main challenges with this was the high cardinality. Because we have hundreds of partners, we need to identify the issues independently. And at DoorDash, we heavily utilize Chronosphere for just general alerting, observability, and telemetry. But with Chronosphere, there is often like a high cardinality limitation that has been like kind of a problem in different areas. But yeah, specifically for this use case, it was definitely a bottleneck. And so that's why we kind of looked for alternative solutions to that. And yeah, so just to summarize the use case again, to support these technical demands, the developer insights team at DoorDash built an anomaly detection system powered by StarTree ThirdEye, supporting 500 plus partners. So a little bit about the data. So in the image there, you can see what kind of like a simplified version of the data looks like. Essentially, there's a status that indicates like the result of an API call. There's an environment column. There's the event source, the developer, who that refers to the specific partner and is an important field, as well as some timestamp columns indicating when the event occurred. So we essentially were able to set up like alerts for all these individual merchants with ThirdEye, and some key features that enabled us to do this. One, on the Pinot side, was the inverted index. Essentially, we want to alert for each partner independently. So the table contains all the data, but when a query is run, it only filters on a single one. So to make that fast, the inverted index is really helpful for that. And we didn't quite get to the scale where we necessarily needed to use it yet, but the StarTree index was definitely something on our minds as well, because for the alert, it's essentially performing an aggregation to calculate how many errors happened in a certain window. So if we wanted to speed that up, we could use a StarTree index to pre-aggregate that as well. And then more on the ThirdEye side, one big feature that enables us to scale this was multi-dimensional anomaly detection. Essentially, that feature allows us to, instead of creating like 500 alerts for all our partners, we simply have one alert, but we specify the developer ID or the partner as the dimension, and it essentially creates 500 smaller alerts. And then also, with that is the query builder feature. So instead of like hard coding all the specific partners or developer IDs that we wanted to use, we could specify a query to enumerate them. So yeah, this is what enables to scale to over 500 partners and have anomaly detection pipelines running for each one of them. And some smaller kind of cool tricks that we used. One was the alert typically looked at a 5-minute window as a data point. So instead of running a bunch of date-time converts in Pinot to translate, the epoch millisecond timestamp to like the last 5-minute bucket, we created a derived column, and that helped speed up performance a bit. And that also integrated with ThirdEye, so it was really easy to set up. And then finally, so that not all the alerts would kind of like be evaluated at the same time, we used like staggered cron expressions so the load was spread out over a larger window. So yeah, this is kind of like the neat features of ThirdEye that we used. And I can showcase some of what this might look like. Yeah. So yeah, this is this is kind of like a mock data set, so it's not exactly one-to-one, but essentially what we had was an alert that was very similar to this, and this is the multi-dimensional alert. So we would have, here there's only 5 items, but for us there was more, and for each one we can kind of see what the view looks like for a specific developer. And yeah, each one of these is run independently, and there's also like a separate notification system for each one. So yeah, that was nice. And then for a higher level overview, so this might be, for example, for the platform team overall to see like how the status of the integrations are doing. You can set up a single alert and then view anomalies for that. And then if there's one that occurred, you can investigate it and view what dimensions are impacting. So yeah, this is something that was a little tangential to the main project, which was mostly to notify the individual partners. But yeah, for like internally for us to use to look at the overall status, yeah, this is also a really nice feature of ThirdEye. Cool. Cool. And yeah, overall, a little bit again on the impact. So driving operational excellence. Prior, yeah, we had to do things manually, but with ThirdEye, our API partner satisfaction increased 60%, and that was reflected in the open rate of notifications compared to before. And at scale, kind of summarizing things again, we had 9 key metrics that we wanted to alert on. This is for 500 dimensions, and they're described to the alert as well. And yeah, this was on live data, which was being consumed from Kafka. And yeah, the detection window was like 5 minutes. Cool. And next, I'll hand it off to Cyril and Subhadeep to talk a little bit more about the technical aspects of ThirdEye.
Hey everyone, my name is Subhadeep. I'm a founding engineer at StarTree. I've been working on this project since its inception, probably 3.5 years now. I'll spend some time on how it all works under the hood. So if you like boxes and arrows, this is the place to be. Okay, so I'll spend a little bit of time talking about what the usual workflow of ThirdEye looks like. So initially, obviously, when you come to ThirdEye, you want to bring your data. And we've made it really easy to kind of bring your data from Pinot. We wire with it very easily. You point us to it. We figure out what your data sets are, what your metrics are. We bring it on board. Next step is obviously, once you have the metric within ThirdEye, you create an alert. Did my page views drop? Did my revenue spike? Did my orders have a weirdness here? So those are the kind of questions that we are trying to answer when you try to create an alert. Once you create a good alert, I'll come to good in a bit, then you obviously want to get notified. And that's why we have notifications built into ThirdEye. So we connect with different platforms, and you can also wire your own. So Slack, PagerDuty, emails, webhooks, et cetera, is part of the default package. So let's say you receive a notification from Slack, and you can come back to ThirdEye and then view whether it's an anomaly or not. ThirdEye values that feedback, and it's really important for us to kind of understand how we are performing there. Now, once you have the anomaly, you can also perform what we call root cause analysis. Now, this is a separate module, which kind of allows you to dive deeper. So we are basically allowing you to do dimension level drill downs, heat maps, and also we bring an event framework with it. So think of it like, let's say, if your orders, and you are an e-commerce website, and your orders suddenly spiked, and it's a Thanksgiving day, it probably makes sense, right? So you see a huge spike in that time. But if it is not a Thanksgiving day and you saw a certain spike or drop, it might mean something different. So the whole point of root cause analysis is to connect an anomaly to an event. Now, once you do all of this analysis, ThirdEye allows you to kind of bring all of that together and build it as an investigation and share it within your team. And your team can kind of come back and add their own stuff to it. So it's pretty interactive in that way. And once you do all of that, you go back and you do a retro and see if this alert is working for us. And you can go back and retune them. So that's broadly the workflow that we see in most of our users. In the interest of time today, I'm going to spend most of our the rest of the piece on detection pipeline. But let me point 3 key areas where I feel ThirdEye really stands out. So first thing I'd call out is security. So ThirdEye actually always handles data. Like you can actually configure ThirdEye to work Pinot, and it does not. So the entire connection is encrypted. So we do not we serve data using HTTPS, as well as we have TLS connectivity with Pinot, and also all the data that we see, we process it and we do a pass-through. Only metadata is saved in ThirdEye, and no other data is actually saved. So that which is really awesome. Second thing I would talk about is something which is a little bit less obvious, is a distributed task scheduler. Now, what is that doing within the system? Well, the task scheduler actually powers the detection tasks. So when you do a daily, minute, or a minute level, hourly granularity alerting, and you're creating all of these alerting tasks that you want to run on a regular basis, that's when task scheduling comes in. When you want to receive a notification on a 5-minute window, on a 1-minute window, that's where your task scheduling comes in. So that is like a core piece of ThirdEye. And also, the plugin framework is another thing that we would call out, because it allows you to make it extensible. You want a new algorithm, you want to bring your own models to do an anomaly detection, or if you want to get actionable with your insights, so you want to consume it from a webhook or do something else. The plugin framework allows you to make it really extensible. All right, so now let's dive into the detection pipeline, which is pretty much the core piece of ThirdEye. So the usual flow is the user would come and create an alert, and we would just save it in our data store. And once we save it in our system, we set up alerts and triggers so that we monitor that alert, and based on the schedule that you have configured, we create tasks. And these tasks are powered by the task framework that I just spoke about. Now, each of these tasks could be different things, but we're now interested to look into what a detection task looks like, and that is what the detection pipeline is. So the detection pipeline is actually a DAG. So think of it like you can have a bunch of places where you can pull your data from, mix it up, and then do anomaly detection. And you can also perform other kind of operations, which I'll get into. But broadly, the data is flowing from Pinot, and you're getting anomalies out of it. So I'll spend some time on talking about what is simple and what is multidimensional. So let's say you have page views, for example. And your page views is coming all over the world, and you see a certain drop. And that's basically what you're creating is a simple alert where you're just monitoring the overall metric. Now, let's say in case of page views, you want to know how your traffic is doing in US versus France versus India. And you have launched in a new country. You want to know how that country is behaving, or whether there's an anomaly there. Sometimes if you have a holiday in a certain country, traffic behaves a little bit different versus somewhere else, which it's not. So all of these aspects make it very interesting to look at multidimensional. And in this case, we have kind of simply said country equal to US, but you can have combinations of dimensions. So country equal to US and device equal to iOS, stuff like that. So this is simple and multidimensional alert that Will was also referring to. Now let's come to real-time monitoring. We do real times from 1 minute up to daily, and that makes a difference in the amount of compute that you need. So a daily alert probably runs once. A minute level alert runs 1,440 times a day. So that's when you need the optimization. So if you have a query that is really slow and you want to run a minute level alert, all of that adds up. Other than that, the detection pipeline actually is extremely flexible and customizable so that you can do a lot with it, which makes it easy for you to bring in your metrics and do custom computations on top of it, which really matter when you want that exact metric to do your anomaly detection on. So we also have things like SQL engine, which there is a lot of detail here, which I'll probably skip. But the underlying theme here is that ThirdEye allows you to customize and tailor your metric so that you can run your detections on top of it. And it also has these additional tools like post-processing, et cetera. For example, I don't want to see anomalies on Sundays, for example, or let's say I don't want to see anomalies which are more than an hour apart, things like that. So there's a lot of under the hood that kind of goes in, and you can tailor the pipelines extremely flexibly in a way to work to your use case. Lastly, I'll just touch upon dimension recommender. It becomes crucial if you have like a large dimensional table. In our cases, we have seen tables with more than, let's say, 100 plus dimensions. And it's important to find what chunk of data is interesting to me. So if I have revenue, is the US revenue matter, or maybe someone in some country where we have hardly just launched? So it really, analysis like this can be automated, and we have built a fantastic tool which allows you to do so. All right, touching a little bit on dynamic multidimensional alerts. Now, multidimensional alerts allows you to do alerting on top of a list of dimensions versus a single dimension. Just think of it pretty much like a for loop. Now, what kind of makes it interesting is that instead of listing all the dimensions, sometimes your dimensions keep changing. And that's what the case for DoorDash, where Will was talking about, where you have a list of vendors that are dynamic. So it's not really, it's actually in a system which is, and it's difficult to kind of feed that same configuration to the alert. So the alert needs to change every time a customer onboards or leaves the platform, right? And that's where dynamic multidimensional alerts comes in. So instead of, so if you see here in the default enumerator is, think of it like a simple list of dimensions that you feed into the system, versus now you actually have a more involved workflow. And this is also leveraging the power of the pipeline, which allows you to create these custom nodes and add them to the pipeline, where we are, instead of just adding a list, we are fetching the data using a query and then powering it through the same pipeline using a join. So in this case, the example here is select distinct country from page views. It will automatically filter in all these list of countries for you and do it instead of you providing the list manually. That's mostly about it. So in a nutshell, that is how dynamic dimensions are helping Will achieve the use case. And I'll hand it over to Sil, kind of go into the more lower level detail of how all of this works. Thank you.
Thanks, Sudeep. So hey, I'm Cyril. I'm a software engineer at StarTree. I've been working on ThirdEye for 2.5 years now. And previously, in my previous company, I was also a user of ThirdEye, and we were monitoring web analytics. So this is the high-level workflow of how things happen in ThirdEye, and I'd like to give you more details about how anomaly detection works. So there are two main challenges for anomaly detection. As we mentioned, there is scale, so we need to monitor at high frequency, and we need to monitor at high cardinality. And then the second problem is, obviously, we don't want too many false positives, so we want the detection to be accurate, but nobody wants to have false positives, but nobody wants to have a data scientist working full-time on building the complex DAGs we just have seen. So let me show you how alerts are defined in ThirdEye. So this is an alert configuration. And as you can see, there is no DAG here. And this is because ThirdEye has this concept of alert templates. And so alert templates are reusable DAGs that can be tuned and configured with knobs. So to get started, you would just pick an existing detection template. You would just set a few knobs, like the table you want to look at, the metric you want to look at, and then you would be good to go. Then, if you want to go further, you have access to all these optional knobs to kind of tune your alert further. So yeah, you have these knobs. Obviously, in the UI, it looks as simple as choosing your template and then just setting a few knobs to get started. So about alert templates, so we provide alert templates with many different algorithms so that you don't have to think about it. You can just pick the right template for your use case and get started. If you're not sure about which algorithms you need to use, you can also get recommendations. So ThirdEye can have a look at your historical data and then suggest what would be the most relevant template. Then this is an example of optional knobs. So let's say you want to do like DoorDash, you want to monitor some metric on every country in this example. Then you would just have to provide these optional knobs. It would take care of running the query to get distinct countries, and then it would run the detection for every country. About algorithms, so we provide standard algorithms like threshold, mean variance, seasonal mean variance. They are a good way to kind of get started or compare the system with existing systems. And then we provide also some proprietary algorithms that we built based on what we learned on the field. So for instance, robust ETS is based on a very well-known algorithm called exponential time smoothing. It can learn seasonality patterns, it can learn trend, but we kind of rewrote it to get some robust properties. And the idea of robust properties is that it can kind of train well even if there is anomalies or bad data in the training data. And this kind of solves the data science issues you may have when you want to work on certain projects where you actually have to clean the data a lot before getting started. Then you have matrix profiled. It's kind of pure anomaly detection for time series algorithm. It's kind of focused on high frequency and is state of the art for some high frequency use cases. And then we have a dimension drift detector. Dimension drift detector is actually the same use case as Uber presented yesterday if you attended the ML feature monitoring presentation. So the idea is that instead of monitoring a metric, you will monitor maybe a column that could correspond to a feature or to some values that should follow a certain distribution. And then if the distribution change, maybe this is an anomaly and you should act on it. Because we have this plugin architecture, if you have some advanced use case, you can also implement some interface and then get your algorithm plugged into ThirdEye. About these algorithms, they are optimized for speed. And so the way we do this is that we re-implemented them in pure Java because we saw that serializing and deserializing to send to some C or Python engine would take some time or would have some overhead in terms of memory allocation. So yeah, this is just an example of to what extent we tuned this ETS model, but one training and one inference takes around 6 milliseconds. So this means that each time we need to do a detection, for instance, every minute, we are able to retrain the model. And this gives a great performance boost because having access to the latest data and being able to train on the latest data improves the accuracy performance. So we've seen that the anomaly detection should be fast and accurate. What about the queries? So this is Pinot. So the idea is that we want to get a kind of time series shape data. And so the way we do this is that we have a time bucketing. This is the first line, like daytime convert. So we bucket the time in this example, 5-minute buckets. Then we group by this time bucket, and we compute our metric for these 5-minute time buckets. And so the issue with this is that if you have a lot of data, computing these time buckets on the fly can be expensive. So it can become a bottleneck. And this was actually a bottleneck for DoorDash. And so what they did is that they introduced a pre-computed time buckets as a new column, such that the group by becomes really cheap. And to do this, you just have to share some metadata with ThirdEye. At the right, you can see you just say, hey, I have these columns. It corresponds to 5-minute buckets. And then based on this, ThirdEye will pick this time column for every alert that use this 5-minute frequency. If you still need more speed, it's Pinot. So inverted index on the bucket, on the 5-minute buckets. Then you can optimize maybe the filtering with some inverted index. And then if you still need more speed, you can always use the StarTree index on the time buckets, your metric, and some other dimensions. Benchmarks. So benchmarks. I don't trust other people's benchmark, so you should be careful about this one. But the idea is obviously it will depend on the data, the number of rows, the resources of your Pinot instance, the metric and the filter you have to apply. But the idea is that this is a data set that has something like a few thousand events per second. And so the default query, the first one we saw, would not scale well. Like it would take more than 30 seconds. As soon as you have the time bucket, the query becomes fast enough. It would take a few seconds. So it would already be kind of OK for most use cases. If you need to have even greater speed, or if you want to reduce the load on the ThirdEye instance, then you can add indexes on filtered columns, or you can also add the StarTree index. So this is for the Pinot speed. And yeah, getting back to the high-level architecture, now we want to kind of make sure the whole system scales. So there are two main components you may want to scale. There is the coordinator and the workers. So coordinator exposes results to the front end. So this looks easy, but for all algorithms we provide for root cause analysis, the coordinator will actually do some slicing and dicing on Pinot data. So it will generate some load. In any case, you're sure it will never stress the actual detection jobs because the detection jobs run on the workers. And so based on the frequency you need for detection, the number of dimensions you need to monitor, you can scale the workers horizontally. Yeah, so this runs on AWS, Azure, GCP. It shares the same platform as StarTree ThirdEye, so it makes things really easy. So these are for the key takeaways. So ThirdEye is kind of easy to get started with these pre-built templates, reusable DAGs. And then if you need to go further, you can always build your own custom templates or even plug your own algorithms. In terms of scales, these are the numbers of DoorDash again. Yeah, we have seen that Pinot will scale, detection algorithms will scale, and ThirdEye itself can scale easily. So that's it for the presentation. So what's next? ThirdEye is generally available, so you should definitely try it. Tons of new, exciting stuff coming soon. So yeah, happy to get feedback and to take questions.
All right, questions?
We have also a booth out there. If you are interested in going deep and looking at the demo, please join us there. And yeah, I mean, our roadmap looks solid, and we are trying to invest in a lot more other things that have been listed here. Data profile monitoring is something we are planning to introduce because, as you know, garbage in and garbage out for any anomaly detection solution. What if you learn about it as quickly as possible so you make sure your insights and detection is accurate? Besides that, we have plans to invest in Gen AI and a few other things. And apart from ThirdEye, you can also see, I think, StarTree serverless. Yesterday, Chinmay and Neha announced about it. That's super cool. That's available, and ThirdEye will be soon available in free tier as well. So it's not too far out. Besides that, I think overall StarTree, it looks promising landscape, as you can see here. With that, we wrap up and open up for Q&A if you have any questions for us.
For the dimensions, that you automatically have your 500 plus partners have alerts, we would be looking at some much larger number if we're tracking like prices of items. And then some of those will have very sparse data. So they're like something embedded that will not cause alerts for items that, or I don't know, is there some way to handle that where there's sparse data for some of the dimensions, where you're not setting them up manually?
So
I can take a stab at that actually. So I briefly touched upon dimension recommender. So one of the things, so dynamic dimensions, the topic that we covered today is more focused on if you have a prescribed list and you want to go through it. You can use the same obviously to go through an exhaustive list of things. Again, the challenge is that some of the dimensions are not important and you don't really care at all. And that's where I feel we have a tool called dimension recommender. What we do is think of it like an objective function on top of each dimension, and then you have some sort of a pruning based on some threshold. So let me give you an example. So let's say you have revenue, for example, and US revenue is much larger probably in some Asia revenue. And within that, you might have different dimensions. So for example, you have device type, you have gender, you have probably state, etc. And you can basically use the tool to specify exactly which dimensions you want to do a combinatorial optimization on, and set a threshold that, hey, you know what, I don't care anything where the revenue contribution is less than, say, 2%, right? And if you do that, then you will probably not get tens of thousands of combinations. You'll probably get, let's say, a much smaller set, let's say 5,000 combinations. And that is a much more tangible outcome to deal with. With the current flow that we have, that's actually wired into the main input system. So you can go ahead and do all of this and just say ThirdEye, hey, you know what, this is my threshold, 2%. Why don't you go create the alert for the metrics that have a 2% contribution to my overall number, and then create the alert. So that's how we tackle the problem that you described. Yeah.
a few things I want to add also, you can use filters. We have noise filters. So you can, based on a guardrail metric, there are several things that is point and click, very configurable. You can do that. In some of our users actually trying to apply filters after the anomalies are detected. So you can consolidate notifications and send to the relevant folks, even if you are monitoring for your own satisfaction, like everything. Thank you, everyone.